I will be showing you how to stretch graphs along the x-axis today. Now let's put in an equation. Our default graph will be quadratic, so that's going to be y is equal to x squared. And this is our graph. Now let's put in another equation which will show us how to stretch the graph along the x-axis. So we're going to put a constant inside the bracket and square that one and see what happens. So let's put it on a slope plot so we can see how it progresses. So that shows a slope plot moving slowly. And there's the graph. So as you can see, the graph has been compressed by a third. So if your constant here inside the bracket is 3, then the graph will be compressed by a third. If it's 4, it will be compressed by a quarter, and if it's 2, by a half. So the greater the constant inside the bracket, the more compressed your graph will be. So let's see if we put in a smaller constant. So this time we're going to put a fraction. So you have y is equal to, the fraction we'll have is a half. So a half is 0.5. And let's see what happens. So square it because we've got quadratic. So as you can see, it shows that the lesser, if your constant inside the bracket is less than 1, the wider your graph will be. Now let's put in another graph. So I'm going to be entering the same default graph. So y is equal to x squared, and then I'll be putting on a new equation, which I will put on an animation later. So first we're going to be putting a constant inside the bracket, and we're going to see. So this time I've put a constant inside the bracket, and let's see how it looks like on animation. So I'm opening the constant controller, and it starts at 1, which is the default graph. And if we increase the value, as you can see, the graph is getting compressed. So let's take it up to 2. So the 2 here as a constant is compressing your graph by a half, and the greater the constant is, the more compressed is the graph. So if we loosen it up, so the lesser the value, the wider your graph is. Okay, so let's put it on animation and let's see how it looks. So there you are. So the graph is being compressed and stretched wider, depends on the constant which is being shown. Now this time we're going to try it on a trigonometric graph, and here our default graph is a sine graph. So let's put in a new equation. So putting in a constant inside the bracket, so let's say 3x, and let's see what happens. As you can see, the graph has been stretched by a third, so 3x compresses your graph. So from 90, it is now gone into 30 degrees here. Okay, so the greater your constant inside the bracket, the more compressed your graph is. So let's see how it shows on animation. So I'm going to be putting a variable inside, k, inside the bracket. So the k will stand for any value. And let's put it on a constant controller. And let's play it. So as you can see, the graph has been stretched compress and stretch wider. Depends on the constant here. If we put it on a family plot, this is what is shown. So this beautiful graph reflects the different constants which affect the stretching process of our function.